All right, hello everyone. Welcome to my channel. This is an educational channel focused on studying up on a lot of theories of everything, primarily theories of everything you've never heard of before, things that I've dug up in the course of my travels and things that I think that could benefit other people if they learned about them. People who are basically heroes of mine for sticking with their guns and, so to speak, and putting out lifelong work that they've never gotten paid for, never gotten any credit for, but they did it because they believed in it. They believed that it was true. They believed they were onto something. They believed it could benefit humanity. And so I'm trying to honor their wishes and get it out there so that it, doesn't rest on the dustbin of history. Now, today is I believe the 223rd video on the reciprocal system of theory. And this is a theory that was first derived by Dewey B. Larson back in the 20th century. He died back in 1990. And he has a few people that are still working on his theory, trying to refine it and improve it and extend it. We've gone through a few of his books and talks and articles. Right now, we're going through a paper that's called Reciprocal Astronomy. This was a paper that I wrote back in 2010, and this is kind of a summary of his very short summary of his much longer book called Universe of Motion, which is on astronomy. It's the third book in his Structure of the Physical Universe series, third and final book. The first book we've gone through called Nothing But Motion, which is primarily on atomic physics, and then the second book is called Basic Properties of Matter, which is primarily on chemistry. So this book is on astronomy. And this is the third installment of this. So if you want to go back 2 episodes, you can catch up by going through those 2 episodes and then listening to this one. Now, we'll start with this visualization of a globular cluster. Consider a sphere, the globular cluster. A large number of smaller aggregates, which are protostars or dust clouds, up to 1 million or more, are contained within the overall gravitational force of the entire aggregate, the globular cluster. The potential energy of each protostar's constituent units, the atoms and the dust particles, etc., is gradually transformed into kinetic energy through gravitational contraction, from having a gravitational field, which raises the temperature of the aggregate. At some point, or at some temperature, the mass becomes self-luminous, and it is then recognized as a star. The point that Larson refers to is the star's first destructive limit. According to Larson, each element has a destructive temperature limit at which it ignites. And then stellar burning begins at the center at element number 117, the highest element, not at element 1. Like the legacy astronomers will tell you that the fuel of the sun is from fusion hydrogen helium, This is actually the opposite, starting at number 117, which is an element that we people in the reciprocal system call it Larconium, but it's basically the highest element, which is only theoretical and never been discovered, and really only stable in different environments than the Earth. But anyway, that is where the stellar burning starts at number 117, and it goes down from there. The gravitational contraction of each dust cloud or protostar continues to heat it at a fairly low level until the center of the star gets to a temperature which is equal to the first destructive limit of the heaviest element in the star, which is also at the center of the star because the star's structure is fluid, so the heaviest elements sink down to the center. The destruction by burning of this heavy element heats up the aggregate considerably until we can recognize it as a star, meaning it's hot enough to radiate in the visible spectrum. The establishment astronomers have no tenable theory of stellar or galactic formation, and they are baffled by the large amounts of dust clouds or protostars all over the place. A major cause for the confusion has been the establishment's insistence that stars burn by converting hydrogen, element number 1, to helium, element number 2. Stars evolve through a cycle that is determined by the concentration and composition of matter in the star's immediate environment. Another visualization, stellar dynamics. Lighter and lighter elements begin to burn at the center of the star. That starts at the heaviest elements, but we move toward the lighter elements. At each element's respective destructive temperature limits, the heaviest elements have the lowest destructive temperature limits. The lightest elements have the highest temperature limits. The matter itself is getting heavier and heavier, inexorably capturing neutrinos over time. The star is, at all times and places, picking up new matter from the cosmic sector. The star also picks up older stray matter left over from explosions. At its center, the star is burning off its heaviest elements at their destructive temperature limits. The net result of all of these activities is measured by motion up the so-called main sequence. The main sequence is the zone of stability of the star, indicating a balance between the progression and gravitation. The main sequence. Stars move up and down the main sequence depending upon all of these variables. When they get cooler and stop burning elements, they contract more, moving down the main sequence until their contraction heats up enough to start burning, which heats them up enough to cause them to expand up the main sequence. These are temporary up and down movements, but over the long haul, stars gradually move up the main sequence, which is the opposite of the legacy scientists who say it's moving the other way on the main sequence, which makes sense because they talk about hydrogen to helium, whereas Larson is talking from Larconium downward. So over the long haul, stars generally move up the main sequence until they get to the top, where they're burning elements all the way down to number 26, iron. Stars on the main sequence are relatively stable for billions of years, at least in Larson's theory. Perret does also chop that number down by a factor of 1,000 or so, or at least 100. And I am certainly open to that. Because of their erroneous hydrogen burning theory, the establishment astronomers' stars evolve by going down instead of up the main sequence, and they have the stars doing backflips and contortions at the bottom of the main sequence, where they become red giants, white dwarfs, and then black holes in quick succession. In the reciprocal system, all of this takes a very long time, but eventually the hot massive stars at the top of the main sequence get to the destructive temperature limit of iron, element number 26. Iron at the center, because of its preferred position on the periodic table, is massively abundant compared to all of the heavier elements. The amount of iron in the universe is much greater than the elements of number 31 and up combined. So, when a star arrives at the destructive temperature limit of iron, a great number of atoms simultaneously ignite at or near the center of the star. With less abundant elements, ignition only causes the star to radiate its heat. But when iron ignites, the heat overloads the radiation mechanism and causes the star to explode instead. This explosion is referred to as a type 1 supernova. When this type 1 supernova is not particularly strong, the explosion speed does not go beyond the speed of light, and the particles are scattered over an immense region of space, but still within the gravitational limit of the star. The matter then slows down, stops, and eventually contracts back into the giant star for a second generation or second incarnation. Okay, part 3, superluminal stellar explosions. A different situation entirely occurs with a strong type 1 supernova explosion. There, the material at the core is blown off beyond the speed of light, ignoring Einstein's celebrated law that nothing can go beyond the speed of light. When an aggregate crosses the boundary of the speed of light, the rules change, just like they did when the motion moved inside a natural unit of space. In both cases, the rule change amounts to motion in time, replacing motion in space, which requires a reciprocal inversion. And this leads to the visualization of a white dwarf. A white dwarf. So instead of exploding out into space, the core of the star explodes out into time. If it's exploding faster than the speed of light, the explosion occurs in time rather than in space, which, by the reciprocal relation, is equivalent to contracting in space. We do not see time, we only see space. So phenomena that occur in time, we see them as the reciprocal of that phenomena in time in space. So the explosion is occurring in time, so we see it as an implosion in space. Equivalent in this sense means that it really is exploding in time, but appears to our senses to be imploding in space. We can only see space, we cannot see time. So what happens is that the strong type 1 supernova creates an object that is actually spread out in time, but appears to us as compact in space and super dense, the white dwarf star. The bigger the explosion in time, the more dense the white dwarf, and the smaller its radius. The white dwarf is so dense that a spoonful of it weighs tons. In general, its mass is as great as the sun, but its size is as small as the earth. And then its companion, the red giant star. Meanwhile, in the same strong type 1 explosion, there is a portion of the matter, the matter originally farther away from the center. That does not make it up to the speed of light. Okay, so in the same explosion, some of the matter is accelerated beyond the speed of light and some of it isn't. The white dwarf is the part that does, and the red giant is the part that doesn't. This matter, the slower than the speed of light matter, then explodes out into space, a normal explosion, in the manner of a weak type 1 supernova. After gravitation brings this matter back together a bit, enough to heat it up, this creates a red giant star. The red giant and the white dwarf thus form a binary star pair, the form taken by perhaps most of the stars in our observed galaxy. Please note that binary stars come from the same exploding star. They are, in a sense, gravitational partners, so they can approach each other less than the gravitational limit. Okay, binary stars. After the explosion, the red giant generally evolves through cooling and contracting in space, and the white dwarf evolves through cooling and contracting in time, seen by us as expanding in space. Both move back toward the main sequence of density and temperature equilibrium. The dwarf from one side, the giant from the other. The red giant generally evolves faster than the white dwarf and arrives back at the main sequence first. The white dwarf takes a long path that has 4 stages before it arrives back at the main sequence. Other than the distinction between strong and weak, type 1 explosions are homogeneous, occurring in hot, massive stars at the top of the main sequence, igniting iron. Depending upon the environment, single stars can move through several cycles of weak type 1 explosions. Eventually, however, the matter in stars begins to reach its second destructive limit, which is not based on temperature, but on age. The inevitable capture of neutrinos over a long period of time makes the matter older and older, heavier and heavier, higher and higher on the periodic table. Neutrinos are really the mechanism for isotopes. So heavier and heavier isotopes. So when matter in a star gets to the maximum age, which is measured in atomic mass units, 236, measured by atomic weight, it explodes. This creates a type 2 explosion. Okay, so the type 1 explosion occurs when iron is ignited. The type 2 explosion occurs when the central element gets to atomic weight 236. Type 2 explosion, which is much stronger than the type 1 explosion. Even a weak type 2 explosion ejects matter at faster than the speed of light. An especially strong type 2 explosion results in the direct addition of 2 units of speed, so more than twice the speed of light. So it ejects matter faster than twice the speed of light, which crosses yet another boundary, not just into time, but into the second scalar dimension of motion, and eventually clear into the cosmic sector. Now recall, there are 3 dimensions of scalar motion, and it takes 3 vectorial dimensions to express just one of those scalar dimensions. We only can really perceive one scalar dimension at a time. But there are 3. And so now with a very strong explosion beyond twice the speed of light, we move into the second scalar dimension and eventually clear into the cosmic sector. We observe this multidimensional motion as a white dwarf star, first scalar dimension of motion, that is moving in a straight line in a second scalar dimension of motion. We can observe only one vectorial dimension, a line or jet. An alternative result to the jet for the type 2 explosion is a giant expanse of space that is moving outward in time, a pulsar. The pulsar results in the lessening of radiation in time. So instead of the radiation process operating continuously every natural unit of time, 1.52 times 10 to the minus 16, less than 1/6 quadrillionth of a second, the pulsar moves out in time to the point that time intervals are so large that off and on periods of the pulsar can be discerned as individual pulses of radiation. Sorry here. Okay, I believe we should probably stop it off right there and get ready to resume tomorrow with a little bit more talk about the pulsar. So I hope this is useful. You're at least getting an overview of Larson's reciprocal astronomy, along with some different categories and how the different categories of stars and galaxies are actually formed in the reciprocal system. And you can compare those with the legacy science and see which makes the most sense. All right. Thanks for tuning in and have a great day.